Hey, I'm Cameron McKenzie. I'm the editor-in-chief over at theserverside.com, and I'm not going to talk to you about llamas with hats. I'm going to talk to you about Java Lambda Expressions, what they are, and how you can use Java Lambda Expressions in your code. Now, here's some code that uses some Lambda expressions. There's one there. There's another one right there. They're nice, they're succinct, they are to the point. Might be a little intimidating for traditional Java developers, but I think we're going to demystify them a little bit here. But before I go in and get deep into Lambda expressions, I just want to remind you of why we need them. There's a lot of places in the Java programming language, the comparator interface is one of them, where there's only one method that needs to be implemented in that interface. So here's the comparator interface here, and you can see the Java 17 Java doc says, well, there's only one method to implement, compare. You pass two arguments and you return a positive value if the first argument should be ordered before the second one, a negative value if the reverse is true. And so how did we traditionally work with interfaces in Java? Well, you would create a class that implements that interface, you would code the method, you would create an instance of that new method in your code, and then you would call the methods and do something with the result. Now, all of that is a lot of work. So what we said was, you know what, instead of creating these classes all the time, especially if we have one simple method to implement, why don't we just create inner classes? And you can see this chunk of code here, well, it does the exact same thing the code on this page does, but there's no interface created here. Instead, we've just said, oh, we need a simple interface that only implements one method, compare. We're just going to sort of create an anonymous inner class here, implement that method, code it up, and life is good. We don't have to worry about all these other interfaces. Of course, the problem is this becomes incredibly verbose. We want to move away from that, and we want to get to a point where we don't have to code like this. Instead, we can code just like this. So I want to show you how we can take this code here and replace all of this verbosity with a Lambda expression. So I've got this file, Lambda examples, which I've started. I'm going to detach it, and I'm going to detach it because I want to actually see all of the code for the anonymous inner class. And so magically, I'm going to take all of this code here, and I'm going to replace it with essentially one line of code by using Lambda expressions. So on the left-hand side, it says, well, we need a comparator. It's going to compare some integers. We'll call it the comparator because we're not very creative with names. And instead of this new number comparator, all of this other stuff, well, Java knows that the comparator only has one method to be implemented. So we don't even have to specify the name of the method. It does take two arguments. So we say, you know what? We're going to take two arguments. I'm going to call it argument X and argument Y. And so I'm going to take an X and Y value, pass it into this compare method. So I'm sort of recreating the code that you see right there. And the implementation for my method is simply going to be X minus Y. And all of a sudden, using Lambda expressions, I've now replaced all of that code with this code over here. I don't actually mention the name compare, because we don't need to, because the virtual machine knows that when you use a Lambda expression, you're implementing an interface that only has one method to implement. So it knows that that method is compare. I specify that it's X and Y that I'm going to pass into the argument, and after X and Y is passed in as arguments to the method, well, the implementation is just going to be X minus Y. Also notice that if you just have one statement implementing the method, you don't have to have a return. So over here we had to say return A minus B. We don't even have to do that over here. And once we're done, we can call that interface. So int result equals comparator dot compare 20, 30, and then system.out.println result. And if we run this code, it's got to be equals, not minus. If we run this code, we'll actually get the exact same result that we would get if we ran the code on the left-hand side. And I'll just bring out my window here, and you can see 20 minus 30 is minus 10, and indeed this code is working correctly. Now, a couple of things I do want to mention about this code. Notice I've got integer x and integer y over here. You actually don't even need to do that. The type inferencing happens with the JDK, the JVM, and so you don't actually even have to say integer x or integer y, and for the most part you won't see that, because the goal is to be as succinct and as to the point as we can be. And so that's one way that the code can be cleaned up, and this will run exactly the same way as it did before. It's also worth noting that, well, it's a best practice to have just one line of code here, but you don't have to. In fact, you can split this up into multiple lines. So I could say int x or int z equals x minus y, and then return z, that placeholder right here. And so in this case, I've got a lambda expression, but it's not one line. It actually spans multiple lines. Make sure you got your semicolon at the end there. And so now our lambda expression isn't just one line. We've got multiple lines. Notice we did have to write the return in here. If it's just one single line, well, you don't need the return, but if it's multiple lines, you do. But again, if I run this application, well, the output window is going to say the exact same thing, because I haven't actually changed any implementation here. I've just sort of changed the code around a little bit. Now again, I much prefer this all being on just one line, so I'm going to tighten that up a little bit here, and now you can see a really handsome lambda expression being used to replace all the verbose code that's on the left hand side. Well, at least on the left hand side before I join that lambda example there. Now, as I mentioned before as well, we've actually got a method here that does some sorting of arrays. We've got an array of numbers, we've got an array of strings, and we do two sorts on them. The first just sorts the numbers from lowest to highest. The second one actually sorts the strings based on how many characters are in them, right? 4, 5, 2, and 6 over here. And this is all done with anonymous interclasses, but I want to show you how nice this looks if you use lambdas. So I'm going to detach this from the canvas. You notice that the beginning structure is the same. The class names are different, but we've got the same string of integers and same array of strings and integers there. But I'm going to do a sort this time simply by using lambda expressions. And so this code over here, I'm going to turn into just one line of code on the right hand side. I'm going to say arrays dot sort that array of numbers, and arrays is a class from Java Util, and I'm going to sort that using a lambda expression that implements the comparator by simply having x subtract the value y and returning the result, numbers. And I can do the same thing for the names. The exact same thing, but differently. And what I'm going to say is, when we do the comparison for the strings, what we want to do is we want to take two strings but compare them by saying the length of the first one being subtracted from the length of the second one. I now save this, and here you can see I've got the implementation of the comparator, but boy, is it a lot less verbose than the implementation over on the left hand side using inner classes. Now to print this out, it's the same lines of code over here. I click Control S, I say run as a Java application, and when all of this runs, well, you notice that we get the results 5, 7, 11, 12, and CJ, Adam, Brian, and Dahlia. Now, the thing is, when you look at this, well, this code produces the exact same results as this code over here. But which code would you rather be tasked with managing? Which code would you rather be tasked with writing? Which code would you rather be tasked with maintaining? And which code would you rather troubleshoot? Well, it may take you a little while to get used to the Lambda syntax, but I think you'll agree once you're used to it, it's a lot better code to work with, especially when you compare it to the traditional anonymous interclasses that we use in Java. Now, if you enjoyed that tutorial, head over to theserverside.com. I am the editor-in-chief over there, and I will say that we've got a couple of follow-up tutorials on Lambda expressions, one on creating functional interfaces and implementing them with your own Lambda expressions, and also some tutorials on how variable scope works with Lambda expressions in Java, and even how to handle exceptions. And we even go as far as talking about Java streams. Now, if you enjoyed that tutorial, as I said, head over to the server side. We've also got lots of tutorials on DevOps and microservices and Java in general. If you're interested in my personal antics, you can always follow me on Twitter at CameronMCNZ. And why don't you subscribe on the YouTube?